right, so this is the overview slide. David asked us to put together a list of topics that we might be of interest to member companies or other teams using Toolchain within Linaro. So these are just some of the topics. These are not all of the topics. So this conversation isn't intended to be constrained to just these. This is what we'll cover for lack of anything else if that's what happens. How do you want to move this forward, David?
Just read it through quickly, I guess, just explain it and then
Okay. So the Toolchain working group works on both the LLVM and the GNU toolchains. There are also some secondary considerations with regard to Toolchain and Toolchain integration that ties in some of the other teams like the build team working on IOP32, Toolchain integration, and providing builds for those, and also releases. So you'll see we have both GCC and LLVM. We'll cover some topics in both of those areas, as well as a brief update on IOP32 enablement, upstreaming, and builds, preview builds, I guess is the best way to put it. And also the topic of function descriptor, position independent code. It's function descriptor, right? Okay. And then, the discussion is going to be, how does this all fit together? What are we missing? Just sort of general conversation. So within GCC, there's a number of issues that are possible discussion points. As many or most of you know, ARM is, or has committed to funding TCWG to continue to work in some areas of the GNU toolchain this year. So we're willing and able to discuss a bit about the particulars of that. The TSC has been informed of this, so they're quite aware of this. Also, we're transitioning GNU toolchain releases over the next year in a soft transition to ARM. And Ramana's here from ARM to chat a bit about that if there's questions that I can't answer. There are probably going to be some questions as far as what our host and target combinations of our cross providers will be, what backporting will look like, what those releases will look like, where they will be in the future, what the cadence and schedule will be. So we're prepared to talk about that a bit more. And also there's ARM 8.2. There's been some questions on that I hope Ramana's can help answer. And also SVE enablement and upstreaming, because that's a bit of a hot topic to some of our HPC-minded member companies. LLVM, our LLVM roadmap is presently, we have a growth roadmap in place, but we don't have a lot of staffing to staff that roadmap, so we wanted an opportunity to present that roadmap and kind of drum up some support from member companies. And then finally, we'll go over the IOP toolchain status. All right, so what should we hit first? Probably what's the first in the list?
Yeah, go to the next slide, or do you, yeah?
Yeah, you can just go to the next slide. So this is just covering GNU. These are the primary focus points of the GNU toolchain over the next 6 months. Some of this covers specific enablement work. Some of it's IOP32 integration work, covering all areas of the GNU toolchain and OpenOCD as well. So this is the way, just a slide to refer back to the actual plan if you're interested. So as far as the ARM funding and the GNU work and the need for LLVM, so we have a high volume of LLVM work that needs to be done. And our original intention was to propose a transition of TCWG to all LLVM. ARM has asked us to slow that down a bit, and therefore was able to provide us with some funding to continue to do GNU work for the next years in the current plan. Whether that continues in the future is something we all need to take a look at when the time comes. But with that in mind, we still recognize that a lot of work needs to be done in LLVM. And so that's when we'll take a look at the LLVM growth roadmap later. But this idea that ARM is funding us might have raised some questions in the past about whether our roadmap as a development team is going to be ARM focused or directed by ARM, or whether members will get what they need from TCWG if this is the case. But that's not, we're here to assure that that's not going to be the case.
But a quick question is, in terms of features arriving, blah, 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 that whole thing will happen wherever it's directed. It's engineers doing stuff.
Yep.
Okay.
Absolutely. We've always sort of held a really close relationship with the Arnold Tools team. We don't have overlap. We try the best we can to make sure that we're coordinating all of our efforts. So we're really more of a team than separate companies in some regards. So we can go on to the next slide. So we're also talking about this transition of the GNU toolchain releases to ARM. This is seen as an inevitability. If Linaro does intend to eventually move toward LLVM, ARM recognizes that they do need to take over toolchain releases for GNU. So this is something that we've started to put into play. This is starting as a soft transition over the next year. ARM member engineers will be using Linaro's release infrastructure to build and release those tool chains in the GCC 6 and GCC 7 release series. And then the target, the soft target right now is that August of next year, the first GCC 8 release will come from within ARM with ARM infrastructure. The intention, though, is to continue to release the tool chains in Linaro's release platform.
Right, and we'll continue to discuss the GCC roadmap, as it were, inside Linaro and the TSC.
Yeah, and I predict maybe around May next year we'll continue to have a discussion about, okay, where is GCC work, where is the LLVM work, you know, how much does TCWG need to continue to work in GNU versus LLVM, and see whether this process continues again for a further year or whether some sort of transition happens.
Yeah, just a question. Sorry, does it imply the backporting effort in the branches as well, or is it just releasing the package?
It implies and includes the entire backporting releasing process. So, Ramana, do you want to discuss a little bit about that?
So we want to see what kind of backporting we need to do, and we would include backporting as part of the release process. I know you've got great tools that will help in that process, so we would like to, we will talk.
Okay.
And in terms of backporting features, we would like to make sure we backport the architectural features that need to be done at the time that we do the work upstream. So we'd like to try and speed that process up a bit as well. So yeah, that's essentially the plan.
And then branch merges?
Branch merges would be, yeah, those are details and we'll have to work through that.
Okay. Ryan, sorry,
yeah.
Another question. How does this relate with the current ARM embedded release toolchains?
We are in active discussions internally about trying to get to one toolchain for all the profiles, but I am not in a position right now to commit to it. It may happen in the future depending on the technical challenges involved. So they operate on a slightly different release cycle. They have one a year, one major release a year, and we'll have to work that one out.
So where the toolchain will be provided?
The toolchain would be provided. We could either have a link from releases.linaro.org to developer.arm.com, or we could host the packages, mirror the packages in releases.linaro.org. But we would expect that there will be a pointer from Linaro's website to wherever it is hosted, because that amount of continuity needs to happen.
Since we're on the topic of releases, I have two questions. One is there a roadmap for native toolchain releases? And second, you have these quarterly snapshots that you do, right, in Linaro. Would that continue? As in, would ARM continue doing that, or is that going to be phased out as well?
So with regard to native, there's never been a strong push within our membership to provide native. I think the expectation is that native toolchains are the territory of the distribution. Yeah. So our toolchains, while they have been and are being used by some member companies to ship some products, they've largely been I won't say proof of concept, but they're a proving point for the integration of all the features in the toolchains. So in a lot of ways, it's a starting point for Linux distributions. It's not necessarily the end point for all users. What was the second question?
The quarterly snapshot.
The quarterly snapshot. I guess Roman is going to have to talk toward the ARM's plans as far as the cadence.
We were considering 6 monthly releases, but we haven't yet thought about quarterly snapshots. But if that is important, we will take that feedback back inside.
That's what we showed.
Yeah, so this shows, I guess the one on the left, the Linaro release infrastructure, shows ARM engineers releasing quarterly up until August, and then shows ARM releasing quarterly indefinitely. That's just my guess. Like Roman says, that's not set in stone yet on their side. So that could be every 6 months rather than every quarter. But this is basically showing the soft transition. So that's the entirety of the slides that I had on the transition and on the ARM funding and the new toolchain work in TCWG. Are there any other questions in that area as far as what's going to be provided or available? This can come from Linaro folks, by the way, as well.
Linaro also provided Meta Linaro for toolchain through Yocto distribution. How is that going to be addressed?
Yeah, so let's ask the question on the mic so we get it on the film.
Yeah, basically Linaro also provided Meta Linaro layer to produce toolchain from scratch using Yocto distribution. What's the migration path there, or what's going to be the story on that end?
Yeah, so my understanding is that the Meta Linaro branch in OE takes the packages that we use to build our toolchains and basically rebuilds their own toolchain with those packages. So I expect that they'll do the same thing. They'll take upstream release checkpoints of existing toolchain packages and continue to do the same thing. There's another option within OE to use an external toolchain, and that's been a way of using Linaro's toolchain in OE. But as far as I understand, that's not used by most adopters of OE. There's no reason why that shouldn't continue to work with the toolchains that ARM provides as well.
So to answer this from a slightly different point of view, that toolchain and that Meta layer is done by a different Linaro team, and it's completely outside of the scope of this transition. So they may continue to do that just as they are doing now to infinity, or they may drop it in the next 3 months. That will be completely besides this transition.
Agreed. And the question, one of the questions I have is, who else are these kinds of users of the toolchain, and what are their requirements? Our basic thing is to try and provide the releases the same way, as much as possible, the same way as Linaro Toolchain group has been providing, so that there is a seamless transition. But if there are other specific use cases where people are doing something slightly different, then we'd love to hear about that.
So could you capture the OE use as something just to ensure? Yeah. Could you capture the OE usage just as keep a note of this, see what's going on, and who cares?
Yeah.
Otherwise, your care-abouts won't be met.
Yeah. So the two places, one or two things that we are thinking about changing from a consumption point of view, dropping certain host and target combinations as well. So, for example, we are going to drop support. We are considering dropping support for 32-bit x86 Linux hosts. So this, we would essentially only provide cross compilers that would run on x86-64 Linux rather than x86 32 Linux.
Do you want to chat a little bit more about your full plans as far as targets and hosts?
Yeah. So in terms of overall plans with respect to targets and hosts, the targets we are looking to drop are ARMv8A AArch32 as a target. We would still be providing ARMv7A AArch32, which is very similar to what the distros use as a baseline. The effect would only be in terms of the libraries that are compiled. The libraries would be compiled to an ARMv7A baseline rather than an ARMv8A baseline. But the compiler would support future architecture revisions as support gets added. In terms of host toolchains, we are looking to drop MinGW and i686 Linux. We are also looking to drop some big endian combinations, especially for 32-bit. So we would like to know what kind of usage there is and what kind of feedback there is to that kind of choice in terms of what host target combinations we provide.
Okay. Are there any other questions on the GNU plan or the transition plan before we get into LLVM? If you have any other questions afterward, both Ramana and I are able to take questions. Oh, yeah.
You had ARMv 8.2 on one of the first slides.
Oh, yeah, sorry, ARMv 8.2. There have been some questions as far as ARMv 8.2 full ISA upstreaming. I just thought I'd give Ramana a moment to chat about that if he can. As I understand it, most ARMv 8.2 has been upstreamed.
8.3 as well.
Oh, and 8.3.
8.2, 8.3 are all available in GCC 7. 8.2, I think, came in. 8.2 FP16 support was fully done for GCC 7. And 8.3 pointer signing was done for GCC 7 again. BNUTILs, all appropriate releases of BNUTILs have the support for the necessary architecture. The first thing we do is really upstream BNUTILs support. So usually, FSF BNUTILs does 2 releases in a year. We usually try and target the summer release as much as possible in case of an already announced bit of architecture. So 8.3 would have come in. I can't get my BNUTILs release numbers absolutely spot on, but it's already there. It's in trunk. It's in some stable release branches. I think it's 228 and 229 should have all the support for 8.2 and 8.3. In terms of 8.2, there was one feature with respect to the dot product instruction, which is an optional extension to the 8.2 architecture. Assembler support for that went in for BNUTILs 229, which was released in June-July 2017. And the compiler support for that will be in FSF GCC 8. Patches for that are upstream and are being reviewed currently. We had a couple of breakages because of which those patches could not be applied. We've had some work done upstream with respect to options rewrite, and the patches when they were done were on the older version and now they're not. So we've had, in case people are backporting that to Linaro GCC 7, there may be a little bit of backport work needed to get that to fit into Linaro GCC 7. But that's actually a pretty useful instruction for people who are trying to do dot product. It will help with handwritten assembly, as well as we'll have intrinsic support and auto-vectorization capabilities. GCC already auto-vectorizes for dot products, and we just have to add the backend support.
All right.
Any other questions on 8.2 or 8.3?
The GDB stuff is still missing because of the kernel patches are not working.
The kernel patches are getting merged in, and we have to take care of getting the GDB patches in. Yeah. This is for 8.3, point assignment. Yeah.
What about GDB for 8.3 for SVE support?
GDB for SVE support is being upstreamed and reviewed, but Yao can give all the details.
So there are two things. The 8.3. So I think the John, the author of the patches, posted the patches, and at that moment the kernel patches were not merged, but now the kernel patches are merged. I think maybe I or someone else to pick up the patches and rebase the patches and send them again. That should be fine, I think. SVE, the upstreaming, the whole process is still ongoing, so some issues should be addressed. But I think some fundamental issues about target description has been resolved recently. So I think there is still only one block on the road, so we will remove them as soon as we can. So yeah, that's it.
All right, thank you.
And in terms of, while we were talking about SVE, let me just finish the GCC side as well. GCC and Behaviour side. So Behaviour for SVE has been upstreamed. There's assembler support and disassembler support. And in terms of GCC support, we are actively upstreaming that and hoping to get that reviewed for GCC 8. It depends on the community whether it gets merged in or not.
Also, all this discussion about SVE and the compiler support, that means enable. It does not necessarily mean that we are going to stop optimizations for SVE, which is a very new framework for the compiler. So there are probably over the next 3, maybe 4 releases going to be improvements for SVE.
Yes, the plan is there'll be initial auto-vectorizer support, and then we'll keep working on it.
All right, so this is the, if there's any other questions, we can come back at the end, or we can, you can grab one of us at the end. So the next section is LLVM. So we have the key deliverables up here just for reference, and those of you that have access to our project tracking, you can access them via the pointers here. So this, we're not intending to actually go over the roadmap at this point. I just wanted to have this here as a reference. Oh, yeah, I'll close that. But what I did want to do is I wanted to talk a little bit about the LLVM growth roadmap. So this is the current roadmap that we're able to execute on. There's a lot of work here, but there's a lot more work to be done. So I'd like to give Maxim a chance to talk a bit about the LLVM growth roadmap. Is that the next slide, David? I think it is. Yep. All right.
So on the LLVM side, we are currently already working on global ISO for 32-bit ARM, but that doesn't mean that there is a lot of work to be done for global ISO, both on 32-bit ARM and for IR64. These are some of the things that we want to work on and will probably eventually work on, but that is beyond our current planning, our event horizon. So for the support for ARM, thumb, hard float, and soft float in 32-bit global ISO is currently beyond that.
Can you talk a bit about why global ISO is important, what the purpose is, and so what the interest is? Maybe Deanna can do that.
Right, so global ISO is a big refactoring effort in LLVM. We're trying to replace our current instruction selection framework. The main reason is that we now have 2 different code paths, one for O0 and one for higher optimization levels. It's quite a monolith. It's very hard to maintain and debug and so on. And it also has a lot of design limitations. So Apple has come up with this new framework, Global ISO, which they're working on for ARC64. And our involvement is mostly to validate that what they do works on ARC64 for Linux as well, because they're focused on their own platforms. And we're also trying to implement for 32-bit ARM. This is mostly because the older ARM backend is much more complex than ARC64. There are more architectures to support and so on, and different features. So we want to make sure that the framework is in good shape and can handle all of this. So basically we don't want the old ARM backend to fall behind.
And also as to why we want to work on this is because global ISL will enable the next level of optimization. One of the problems in compilers is that it's difficult to do instruction selection and register allocation. These two optimizations interfere with each other, and in most compilers they are done sequentially. Global ISL tries to address this problem and do parts of register allocation as part and account those restrictions in the instruction selection, which has a very good, big impact on the code generation quality.
So when we look at effort in global ISL, is it something that we consider easy, or is it something that's very time-consuming? How long are we looking at? Is this something that you could work on indefinitely, or is this a simple problem? What I'm trying to do by asking that question is to put it into perspective why this is in our growth roadmap, why this is, to describe why LLVM isn't just something easy to do, why we need more involvement.
Well, obviously, as you can probably guess from the slides, there's a lot of work to do because we have a lot of instructions to support. And right now there's actually some work in progress in the community, so we can use more of the existing support from the existing instruction selection framework. So hopefully, I'm hoping the amount of stuff that we'll have to manually put into global ISL is going to decrease. But we have to keep an eye on this and review batches upstream and make sure they can handle all the ARM patterns properly.
Let's move on to the next slide.
Yeah.
So next one is LLVM linker. These are things that we want to work on, but currently we don't have resources to do that. The work we currently do on LLVM linker is to enable it on ARMv7 32-bit, so that it can be used to compile pretty much all normal packages. Peter recently accomplished that, hit the milestone with his work that FreeBSD distro can be compiled with for ARMv7 completely with LLD, and that required some extensive changes to the linker.
And why was FreeBSD an important milestone?
Because it's the first big distro with tons of packages to compile to linker using LLVM linker. And as to why you should care about LLVM linker, generally it's the same reason why you will care about LLVM compared to the GNU toolchain. It has the license and it has the ability to do downstream optimizations in the linker. And currently, LLD works well for x86, Peter?
Yes, it's also, I think.
The two most heavily used backends for LLD will be x86-64 and ARC64, where there's quite a lot of sort of internal usage of those particular targets. I think it's probably only really the BSDs that are using it right now, mostly because a lot of the major sort of server-like distros are using ARC64 for that sort of work these days. But yeah, I think it's certainly been now production ready, and we would now expect things to work. And if things don't work, file a bug rather than well, try it and it might work. So it's certainly there. I'd say that the other reason to use LLD is if you've got a very large program. It's measurably faster than Gold and BFD in most cases.
And that's for the current use cases of LOD. As LLVM-based toolchains for embedded market will start to emerge, those will really want to use LOD. And people will start requesting us why, start asking us why LOD does not work for my Cortex-M target. And we want to prepare and make it ready when that demand arrives.
Yes, just for that topic on toolchain for embedded on the market, ST put a lot of effort in the new LD, and ST sees LD as the best candidate for that kind of toolchain so far. So yes, we want to know if it is something which is which the others have the same feeling about that, or if LLD can be a good candidate in the near future for that.
This seems to be one of the issues, or one of the areas where no one needs it until they do. Where it's not a candidate right now, obviously, because it's not enabled. But at some point, it will be enabled, and it will be probably very desirable.
I think from what I can see on the mailing list, again, this is not something I've got definite knowledge of, is that there's quite a lot of people taking LLD and making their own downstream specific version from some of the changes that we're getting, or patches coming up. There are people who are using it for embedded systems, and but they're not doing necessarily in public, or the targets aren't necessarily in public. I can't see any reason why how it's written at the moment can't make it work for embedded. I think it's just mainly a case of testing. And if there's, I think the thing where it would be most difficult for the sort of wackier embedded features that quite a lot of embedded toolchains have, where the libraries and the linker collude and whatever, whether you'll ever be able to get them in the upstream release or not. But I think it's one of these things that people can build on that with their own downstream patches.
Yeah, and that's one of the missions of Linaro, to make sure that our members don't do the same hacks in their own downstream trees. So we want to work on that.
I also don't think the question is or, I think it's an and.
You mean
it's not no LD or LLD, I think it's no LD and LLD.
Any other questions on LLD? Yep.
Yeah. We can always do more and better with the vectorization. It's such a difficult optimization. You can bang your head against the wall with vectorization all day long.
So this is basically a description of what's uncovered right now, with what we've identified as possible things to work on that we're not currently staffing.
Okay, next.
Yep.
For libc++, there are several, we are not currently working on it. So we know that there are existing problems with libc++, which is the C++ library used by LLVM compiler. We need to fix this to make it feature complete, on par with the GNU toolchain, so that people can take out one toolchain from their project, put it in another, and it will just work.
And the implication of Linaro doing this work versus the downstream should be obvious. If there are members who are using LLVM, it's possible that they're actually implementing their own C++ libs in the back end, and if there's redundant work being done, maybe that work should be done within Linaro rather than done in all the back end, or in the downstream implementations.
So I just had a question when I noticed the interoperability between libc++ and glibc. So many years ago, you had libio, you still have libio, which was used by libstdc++ for streams compatibility. Does libc++ by any chance do something like that? Because one of the things that we are planning to do in glibc is to deprecate the lib.io nonsense, because it's basically cruft now with all of the vtables, and kind of come up with a simpler implementation. And if libc++ is using that, then it'll probably stand broken.
To my knowledge, it doesn't.
I hope it doesn't.
No,
because
as far as I can see.
we really want to get rid of that.
There's no dependency on lib.io.
That's good.
And this is important as well because this is addressing things like how to deal with exceptions for binaries that are sort of mixed environments. Right?
Okay. Next one. Cross compilation. So in LLVM. LLVM is the compiler can and does support cross compilation very well. But to cross-compile libraries for LLVM is a very difficult task. So far, to my knowledge, people are doing this downstream, primarily on making their own proprietary toolchains. However, this should be fixed in the upstream. Also, LLVM libraries are used outside of LLVM project, and there are several build harnesses for those libraries. I know one is in Android, and they're using their own build system because it's just too difficult to use LLVM solve. And it's kind of ridiculous. That should not happen. Android should not use its own scripts to cross-compile and build. Well, they're not necessarily cross-compiling, they're building LLVM libraries, because that's potential for a mistake. And we have seen bugs in LLVM due to people not using LLVM's own process to build and test libraries. So we need to fix that. Target parser.
This is something that we had member engineers helping us with for a while. There has been a larger goal to move toward a new target parser. The community recognizes that this is an objective. Presently, this is not something that we are working on, though we're all aware that it does need to be done.
Yeah, and LLVM's current handling of targets and compiler options is a very difficult place to change something without breaking something else. So it's accepted by the community that this needs rework. Unfortunately, companies who are investing heavily in LLVM work around this in many different ways downstream, which...
Yeah, I'm actually aware that there are some member companies with downstream compilers that already have a table gen backend that just isn't contributed because it's encumbered by IP or proprietary knowledge. So this is already happening in some places. It's just this should happen in the default implementation.
There are quite a few of LLVM bugs that some of them we do have bandwidth to work on and do that, but I think it's only a small fraction of all the bugs. As a team, we generally investigate problems which break build bots, LLVM build bots, and fix those. We do not have enough bandwidth to investigate long-standing LLVM bugs. This is something that we can do to clean up LLVM scheduler, which is an optimization targeting individual cores in LLVM to make it easier for our member companies to contribute their own scheduler models. There is a bit of unification that can be done here, and also general improvements and cleanups so that a new company coming up with a new microarchitecture has a straightforward way of providing compiler with a description of what its pipelines are like. this is quite similar to the option processing target descriptor.
Do you know a bit about this one, Deanna?
I guess. Right. So in LLVM, each core has a set of sub-target features, which are usually, for instance, whether or not it supports certain extensions or VFP or Neon or that kind of stuff. But we also have some features which are more or less hacky. And the problem is that people write a lot of code where instead of checking these features, they just check for the core directly. So they say, is this a Cortex A9? Is this whatever, Swift or what have you? So the code is full of such calls, so it's difficult to reuse because you have to go all around the code and search for places where things can be tuned and add your own code there. And instead, we'd like to have something more unified, where you can just describe the core, have these features, have them make sense, and when you add a new core, just say which features it has and which it doesn't, and take advantage of all the optimizations and everything.
So this just, the way it is now, incurs a burden upon everyone, every downstream compiler creator, and it makes sense to fix it in one place.
Next one. Test suite and benchmarks. There is an extensive LLVM test suite, which can use a cleanup on one hand. On the other hand, it does not test all the things that we want it to test. This is mostly a work item for the benchmarks, because when we are working on optimization for LLVM, we do test it on both x86 and ARM targets. On the other hand, community who contributions from the community who are not interested in ARM and x64 may not test it. There is a framework in LLVM so that the benchmarks are run automatically. However, the number and scope of those benchmarks does not necessarily cover all the areas that ARM targets are suited for. So we need to make sure that we add the benchmarks relevant to ARM into those repositories, and that everyone runs them when they're committing performance-related changes.
How many slides?
It's about done.
Okay. I just want to make sure we get to Nicos question.
And this is improvements to our own infrastructure to make sure that we have extensive, while in the previous slide it's mostly micro benchmarks. This is about running real world big application and benchmark suites like SPEC. We have a huge backlog of performance issues at Linaro. We would like to make it smaller. Next slide. And debugging for enhancements. On the one hand, LLVM has very good support for warnings and printing out compiler errors for the code. On the other hand, it's debug enforce support, which is what allows the debugger to show source lines against executed code, can be significantly improved. It's, I believe, is nowhere near where other compilers debugging for is. This is a very difficult task. Improving debug information is as difficult, if not more difficult, than making compiler optimizations.
Do you have some bugs that say the client doesn't generate the debug information properly, or you have some complaints from other people?
What I've heard is the problem is appropriately placing debug information due to optimization.
Yes. So yeah, I think the ARM people has already several months ago. Some people use LLVM also complained to me about the data information. But that only happens with the aggressive optimization is applied during the compilation.
It's not so much that it's more
size optimization.
It's more that if the debug illusion is good at 0,
yes.
It's not good at 01.
Right.
And if you're on an embedded device,
yeah. So what I want to say is there is nothing specific to climb. I suppose if you use GCC and with a very dashboard 3, something similar.
Peter just said 01, and at 01 GCC is pretty good at its debug info, and there was a lot of work done in GCC for debug info.
So I think that's enough on this one. Okay. So let's hit Nicos question, make sure we have time, and then we'll pick up with ILP32, because ILP32, the discussion could either end quickly or it could go on for a very long time. So let's make sure we get Nicos question.
Okay. As people who've seen my talk probably know that I'm working on making Linux tiny. So I'm working mainly with CPU without any MMU. And one problem I hit is the user space. The current format for MemuS on ARM is currently the BFLT format. It has some shortcomings, one of which that it's hard to have the text segments separated from the data and to share a single text segment with multiple processes. One solution to this is the FDPIC format. And fortunately, those really nice guys from ST did the work already. They did the kernel part and the toolchain part. What I did is I forward ported their kernel patches on top of the recent kernel. It is going to be merged in the next merge window. The problem is the toolchain support is based on GCC 4, and I was wondering if there is some space in the resources that we have to forward port those things to the latest GCC upstream.
So, as to give you a direct answer, at the moment, no. But we hope that TSC will, well, first of all, if there is a member company who would provide us IDs for this work, yes, we would definitely prioritize it.
How big a job is it? I know, how long is a piece of string, but you know, is it big, little, tiny, huge?
Of course, I wouldn't speak for them, but I would expect that ST1 might be interested as well, since they did the original work.
Yes. Yeah. So I would guess between 6 months and 1 year for one engineer.
Okay.
So yeah, this is not a tiny project because the toolchain is somewhat old. On the other hand, we can do it. We can execute on this within 6 months and pessimistically 1 year. We are going to talk with the TSC how they feel about us taking this on, because this is not blessed. On the other hand, as a team, as a toolchain team, I would really much like us to work on this. Right. Because this is exactly the task for Linaro. In the ideal world, ST would have contributed it itself. But
I remember Christian raising this a while ago. And as for the TSC, you've got the chairs of the TSCs that sat here. So is it? I don't think we've got time to do it here because we've only got one more meeting left. But we can raise it quickly if we need to. I mean, the next two, whether it's the operational or the strategic one, we can do it.
We just need to know what displaces.
Yeah, it's Tetris, right? Yeah.
I think that an existing ST assignee could work on that.
Okay. So you have the knowledge. It's a question of what they're doing.
Yeah.
Yeah.
The one holding the microphone.
I was guessing.
Yeah, so the FDPSC has been supported in GDB for several years, but it's for the SH architecture, so I don't worry about the FDPIC stuff in GDB. That's the big.
Okay, so there's some upside to all this at least, you know.
Yeah.
So the action is for us to raise it with the TSC and plead the case.
Yep.
Okay.
Have all the ELF ABI changes made it into the ELF spec from ARM? Before we upstream all of these things, putting my upstream maintainer hat on, I'm going to say, where are the standards? Have we done all that?
I am not sure. I know.
So a lot of that has to happen.
There was work in progress for that, but I'm not sure that of the current status.
We'll
also putting my GCC steering committee hat on, I'm going to ask the question, who holds the copyright to the code?
That would be the biggest problem upstream as well. Without the documentation, without the specification, it's going to be impossible to get anyone to take it.
Well, let's not prejudge what there is or isn't, but part of bringing it to the TSC is finding those questions.
Right, and also...
So could you make sure that Ryan's got your questions so that we can answer?
Yeah.
Yeah, we'll address this in the post-connector.
Yeah, thanks. Yeah.
There are a couple of things.
No, good points.
Good
points, Roman. I get completely that. Okay, so there's some actions on us there's some actions on us, or Ryan, and me and Mark, to bring this to the TSC quickly and see where we are. But we need to sort of have all the information.
Yeah.
Thanks.
Anything else on FDPIC? Nico, did that cover all your questions? Okay, thank you. All right, David, can we back up and hit the IOP 32? So, Maxim, we can take this one from the top, I think, and then I'll cover at the open embedded. One, next one.
Okay. I need to go somewhere in there. So.
Okay.
So the
I'm going to take my
IOP 32 effort. Toolchain team provided a preview grade IOP 32 toolchain. We made it using the same harness that we do our normal releases. So providing any updates is for us the same cost as providing releases. We are going to do that for the next foreseeable future, until the IOP 32 effort leaves or merges.
So the IOP 32 GDB patches are not merged with GDB 8.
I did not. Are there IOP 32 patches for GDB? Are there changes required?
There are some patches, but not merged from Caviar.
I thought the only pieces missing are glibc and kernel, so thank you for that comment. We'll ping our Caviar friends about this. For the so what our plans are, we are going to provide ILP32 binary toolchains. These toolchains are tested to the same criteria as our normal releases. There are several known issues. Next slide.
Well, we're out of time.
Yeah, we're pretty well out of time.
So you're supposed to allow transition and...
Yep. So there is
There
is additional information here on IOP32. We do have distro, Debian distro support for IOP32 work ongoing in process, and as well as open embedded support. So I believe there's a preview grade toolchain, and there is a preview open embedded release for this as well at this point, and Debian soon to follow. So if there's any other questions on IOP32, please feel free to come and contact me. All right, thanks very much, everyone.